Okay, hello once again for another Cyber Defenders CTF. So this time we'll deal with this challenge, Malware Traffic Analysis 2. Okay, I already solved part 1, so you can go back to my previous videos. Okay, so the challenge here is another PCAP. Another PCAP was given to us, so you could download the challenge and compress it using this password. And the important tools to have are suricatarunner, BrimSecurity, WireShark, of course, since we're dealing with PCAP. And you have to follow the instruction here. Of course, there's a setup guide here. Okay, so best if you could watch this and follow it uh, for you to really be in a good shape to investigate the PCAP sample. Then once it's done, so the details really are nothing much but PCAP that belongs to an exploitation kit infection. Okay, so as mentioned, here are the tools. And if you have done everything, we can now proceed. Question 1, what is the IP address of the Windows VM that gets infected? So once you have it opened on the suricata, or I mean the Brim, we can actually go to suricata alerts by source and category. Right here, you have the quick overview of what's happening with the PCAP. And notice here, as you can notice here, many strange, suspicious, and even malicious activity is being found on this IP 172.16.165.132. There's Trojan. Okay, there's a command D code. There's an exploit kit even, right? Another exploit kit. We can say that we can deduce that this IP is the one infected, right? Of course, it has to be a private IP. So if you're not familiar with private IP, best to be familiar with those. So you can investigate or quickly what's the compromised internal IP. Okay, what's the public IP connecting to the compromised IP, something like that. Okay, we got the first question. This the IP. The next, what is the MAC address of the infected VM? So given that we know that this is the infected IP, okay, let's try to do it or check the WireShark. Actually, we can already see the infected IP on the very first packet. And when we know that WireShark contains all the details, it can show us all the details on the packet from each layer. So it could be found on the Ethernet. And just under the Ethernet section of that packet, simply search the source, and under the source actually is already the MAC address. Okay, this is already the MAC address. Okay, which gives us the answer right here. And the third, what is the IP address and port number of the delivered the exploit kit and malware? So again, I go back to Brim. Okay, notice here, there's already a signature here. That's the beauty of the Brim. It can correlate the signature of Suricata. So here we see the exploit kit. So most probably this is the IP that delivered the exploit kit. So you can pivot to the logs to see the further details. Okay, you can see here the source port, destination port, right? But it's not actually the answer. So there's another event of exploit event, which is just beneath. Okay, it's just under here. 37143. Okay, you can again pivot here. Okay, the next exploit event from the same IP 37.143, not 15.180, is the answer. This is the destination port that was used. Okay, And then the next question, what are the two FQDNs that deliver the exploit kit? So given that we already know the IP address, okay, let's just go back to Brim and go to the HTTP request. Okay, HTTP request, then sort the second column and find the related HTTP request for that IP, which is the 37.143.15 here. Notice here there are two FQDNs, the h.trinketking.com and the g.trinketking.com. Okay. Okay. Next, what is the IP address of the compromised website? So here, let's go back to Brim. Okay, go to Brim and we have to really check the referrer URL of the domain that delivered the exploit. So we can sort this again on the second column. And if you recall in the previous questions, these are the domain that delivered the exploit, right? g.trinketking.com and h.trinketking. So let's check for the referrer URL for this. So we can go to the HTTP request, and for example, let's filter this. What happened? Filter value. Okay, let's change this. Example, the trinketking.com. Okay, Trinket King H. Okay, let's go back. I think I have done something wrong. Okay, here, HTTP. Okay, we can filter, for example, this. There. And then change this to the domain involved in delivering the exploit. King.com. Okay, and then observe the referral URL for this. So notice here, we have here another suspicious looking URL. So you could double click to get the details, and we could actually copy this, copy and hook it up in the virus total. Virus total. Okay, so search, and you can actually reverse look up this on any other OSINT tool, but virus total is the preferred choice. So you can see here, this is the serving IP address for this, which is actually the answer, right? For next, what is the FQDN of the compromised website? So yeah, this is what we have looked up. So it's hijinksensuwe.com. Okay. Then what is the name of the exploit kit that delivered the malware? So again, you can go back to Brim, the name of the exploit kit. So we could go back here, source alert by category, and we can pivot to this related only to exploit kits. And on the resulting logs, you can see here the name of the exploit. It's actually Sweet Orange. Yeah, you have 4 instances related to Sweet Orange. Okay. Okay, for the next, what is the redirect URL that points to the exploit kit landing page? So actually here, if you will recall, this is the domain, exact domain that delivered the payload, the exploit, right? So we can go again to the WireShark and we can trace for the first instance that the DNS query was made to that domain, which is actually around here. Okay, the first first query, okay, to that domain actually happens here, the packet 1212. Okay, so again, when you do investigation, you could actually pivot backwards to see what triggered this DNS request, right? So what we're going to do is we're going to clear this out and trace back a little bit. So is that the preceding packet actually leads to this DNS query to the exploit or exploit domain, so which is this one. And the request actually here, you could find under the HTTP request, which is actually here. You can see here, HTTP static that Charlotte retirementcommunities.com, and it has called a parameter TSTMP with the number. And actually, if you will inspect it further, you could see here in the text data some sort of obfuscated script. So most probably, oh yeah, this one. This is actually a JavaScript, text JavaScript type. Okay, so this is actually the answer. Okay, let's go back. This one. Okay. Okay, for 9, what is the IP address of the redirect URL that points to the exploit kit landing page? So this is basically reverse looking up, DNS lookup of this site. Of course, we'll use virus total again, and it will give us this IP, as you can see here in the answer. Okay. Okay, number 10, extract the malware payload from the PCAP. Okay, and we are to get the hash. So how to do this? I'll go back to WireShark. You can do file, export objects, and then HTTP. And recall from earlier question, the domain that is involved in delivering the payload is trinketking.com. So notice here we have 3 HTTP requests related, and since we are getting the PE file, so it's only h.trinketking that has an application or octet stream HTTP related request. So this is the one we want. So you could save it. Save. Okay, we could put it in a download. Okay, I actually did it earlier. Okay, we can replace. Okay, you see it's already existing. So once you have saved it, you can close this, go to the downloads, and we want to take its hash. So you could either right click, there's a CRC hash computation here. You could do asterisk for all. I don't know if it has MD5, right? If there's no MD5, the easiest way is to upload to virus total. Okay, which I did. That's why I get this. Notice this is a malicious file. Don't execute it if you're not sure or if you do not know how to handle malware. Okay, and that's how we got this answer. Okay, what is the CVE being exploited? Okay, we can see it in the Brim actually. So in the Brim, we could go back to the source suricata alerts by category and filter the exploit kit related logs. You can pivot to it, and it actually shows you the actual vulnerability being exploited here. Okay, it captured on the signature CVE 2014-6332. Okay, that's the answer. And then for the next, what is the MIME type of the block of the file that took longest time to be analyzed using Zig? Okay, for this, we could actually go to Brim, TBT overview. Okay, you could actually remove this query, just this, sort our duration. Yeah, we could use duration as the sorting parameter. And notice here, Okay, let me go back. The overview. Okay, the files. You could filter for the files. Yeah, sometimes this happens, so you could remove the count by. Okay, there. Then we could use duration. Okay, as the sorting mechanism. And notice here the MIME type that has took the longest to load or analyze by zip is the application x-dos exec file type. Okay, with 5.1 seconds. Okay, that's 12. For the next, what's the referrer for the visited URI that returned the file f.text? So let's go back to Brim. You can find it in the HTTP request. Go back to TBT overview rather, filter HTTP logs, and you could actually just add another query here f.text. And this is actually the referrer that returned f.text. So the f.text actually can be found in the column response file names here. Okay. Alright, so that's the answer. And then when was this PCAP captured? So go to WireShark and just check the dates or even in the Brim. Okay, you can check the dates of the packets. Notice here. Okay, the very first oh yeah, the packet as well is 11/23/2014. Okay, then when was the PE file compiled? So remember the PE we have extracted. So you could see the compilation date on the creation time, which is November 21, 2014. Okay, so number 16, what is the name of the SSL certificate issuer that appeared only once? So we are asked for just one word. So to do this, go back to Brim, and we are going to search for the SSL events. So we can actually change this query at SSL. And of course, we have to find the issuer that occurs only once. So scroll to the right, and you can see issuer column. Okay, notice here there's only one issuer related to one instance of cyber trust. Okay, and that's actually the answer. Okay, questions. I think this time my anyways. Okay, there, cyber trust. Then for the last question, what were the two protection methods enabled during the compilation of the present PE file? Remember the PE file we downloaded? The malicious one, this one? Okay, so we have to use, for this we have to use the wincheck, this one. We have to use the wincheck sec that executable to inspect that malicious PE file. So we could download a copy of the wincheck sec here in the GitHub. Okay, and to know more details about this, so this is actually a useful tool to inspect PE for malware analysis or for malware reversing. So you could read more info in the GitHub page right here. So you could actually build on your own, but I prefer to download the compiled tool already to save me the time of compiling it. But if you want, there's a instruction for building on Linux or Windows. Okay, and the usage is this, so it will check the PE file for the presence of this. So presence of ASLR, high entropy, isolation, NX, SEH. Okay, so the basic usage is just win check sec.exe and then point it to the executable that you will be inspecting. So in this case, notice here I just point it to the downloads, and then this is the downloaded PE file from the WireShark from previous earlier questions, if you remember. Notice here, these are the results. So it found isolation NX SEH. Okay. So for NX, a quick Google search it will result to it's actually related to DEP, data execution prevention, and for the SEH, that's the structured exception handling. So you could check the link to learn more what are those protections. Okay, so that's it.